Okay, so happy everyone. Last time I have finished part of like a partial of session 3.1 in Math 180 basic calculus. So today I'm gonna continue to finish this session 3.1. Let's talk about relative maxima and minima, right? So what is a relative extrema and critical values? The critical value can but do not necessarily produce relative maxima. Okay, so you know how to find the critical value, right? So basically, from the critical value, uh, you can find the from the critical value you can find the maximum, relative maxima and relative minima. Okay, so relative. Okay, the term of relative extrema is used to describe point that can be relative maxima or minima. Okay. So, so we're going to talk about the first derivative test. So if C is critical value, okay, of the and Fx is increasing immediately to the left of C. So here is C, right? I have a number line here, and here's C, and here's a from somewhere like negative infinity to positive infinity, right? So if Fx, say here's Fx, is increasing to the left of C and decreasing immediately to the right of C, then then C produces the relative maxima. So in here it's gonna be maxima, right? You know that's like a mountain, it's go up and down. So then this part gonna be a peak of the mountain, right? So this also is a maxima, the highest part of the mountain. So and for the in term of the first derivative, in here, according to the part 1 3.1, you should know that since fx is increasing, then f of x has to be positive, right? And since fx is decreasing, then f of x has to be negative. I'm gonna change another color so you see it clearly. Okay. In another case, we get number 2 here. You can see that if fx is decreasing immediately to the left, so say in another case here, I have C here, negative infinity, positive infinity, is decreasing immediately. Here's fx, right? And to the left and increasing immediately to the right. Then this has to be the relative minima. Okay, so I say relative. Okay, and also in the interval from negative infinity to the C, you should have f derivative. Let me change the color. F. Oh, what happened? F derivative x for this, change this. I'm gonna have this, so I'm gonna separate this better. Okay, okay. So if f derivative of x gonna be negative and then positive, right? Maybe I'm gonna also separate this. Okay. So for this case, you see that you are go from up, down, and go up. Then this part here has to be relative maxima, a minima. Okay. So in the figure here, you can see that you can see that this is a function of fx, right? And from the first part here is going up, right, to the at 30. It's going up at 30, and then it stop here and going down, right? Then I'm gonna call this, at this point we have relative maximum, right? And then from the relative maximum is going down until x equals to 7. It stop here and going up. So then you gonna have at x equal to 7, we're gonna have relative minimum. Okay, and I'm gonna say relative minimum is at 7 and f7, right? X and y here, and another other pairs for the minimum are gonna be 30 and f30, right? Okay, so let's have an example. Okay, example 4. I want to find the relative extrema for fx equal to x4 minus 8x squared. Okay, so first step, okay, I gonna list some steps for you. Step 1, you're always gonna find the critical value for that. Maybe use a color. So find the critical value. Step 1. Okay, and then in order to find the critical value, you have to take the derivative of fx, right? You should know that the derivative of fx is 4x cubed minus 16x, okay? And domain in this case is x, because this is a polynomial, so then domain is x is all real number. So so I don't have to worry about the undefined case of the derivative of x. Okay. So now I'm gonna go to the step 2. No, actually it's still in the step 1 because it is 5 critical values, right? So after finding the derivative of fx, I need to set derivative of fx equal to 0 over here. See that? And from here, I gonna substitute f derivative of x equal to 4x cubed minus 16x equal to 0. Right? And then for this one, I always have to think about, can I factor for this expression, right? I know that I'm gonna have 4x is greatest common factor between these two terms. So I'm gonna factor out 4x and then I left with x squared minus 4. So then the right hand side still equals 0. Okay, so in this case, I will from correct algebra, I will apply a zero factor probability by let either for x equals 0 or the factor x squared minus 4 equals 0. And then for the case that for x equals 0, I divide by 4 both hand side, I got x equals 0. Okay. And then in another case here, I'm gonna add both hand side by 4 to get the x squared equal to 4 here. Right. So next step, I still keep x equal 0, or okay, you're gonna square root both hand side, right? So you're gonna have square root x squared equal to square root 4, and using the square root property, I'm gonna have x equal to 2 or x equal to negative 2, and that's give me 3 critical values. Okay, so since I have 3 critical values, I'm gonna come to step 2, right? Now after I finish finding the critical value, I'm gonna move to the step 2 and say set up side table. Side table test. Okay, and still want to color this. Okay, and now the setup side table test, or actually I got like no, it's number line test, but side what's that called? I forgot. Let me see. Side chart. Okay, so set up side chart for X. Okay. So now I will have a number line here. Actually, I'm gonna move up here. I'm gonna have a number line here. It's gonna go from negative infinity to positive infinity. You know what? I'm gonna have a little bit longer because I have 3 critical values. So it's come from negative 2, 0, and then 2, right? For each of these intervals, I had to choose some test value so I can check for each interval what happened with the f equal x. So I have f equal x here, and then I'm gonna have a line, and then f of x. I'm gonna put a value of x up here. Let's say from negative infinity to negative 2, I'm going to choose a value that's inside of this interval, say negative 3, right? From negative 2 to 0, I'm going to choose negative 1. Let's change the color so you can see it easier. Negative 1, right? I change this one. And then from 0 to 2 is 1, 2 to infinity, 3. Okay, now I'm going to test at negative 3 for x equals to negative 3, what happened with the f derivative of x? You can do a side work. Say f derivative of 3, what is that equal to? You know that the f derivative of x I'm having right now is this 4x cubed minus 16x. So I say 4x gonna be 4 negative 3 cubed minus 16 times negative 3. So if you are using calculator, let's say 4 times negative 3 over 3 minus 16 times negative 3. And then you enter that, you're gonna have a negative number. So that means what? Equal to negative 60, right? So that means you have a negative here, okay? And from here, from the f divided by x having a negative, then you want to say, oh, fx is going down or decreasing here, right? Okay, so I know that let me have here go up a little bit so people don't wanna go up a little bit. 0 here, 2 here, okay. I actually can also have like a line here, so I can separate that, right? Okay. So negative here. From at negative 2, I know that at negative 2, f divided by x has to be equal to 0 since this is a critical value. So I have to put it to be a 0. Okay. I may gonna have here at the minimum. I think that, but let's check. So I'm gonna put negative 1 into f divided by x. I have net f divided by 1, have 4 times negative 1 cubed minus 16 times negative 1. So we're going to have what? 4 minus 4 minus 1 going to be negative 4 and then plus 16. So you will have what? You will have negative positive of 12. Does that mean a positive number? And you can say, oh, it's going up. Right? And I can right away say, oh, this guy is a relative minimum. So actually I'm gonna have, oh, so min, right? And you should know that for the value of x equals 0 and 2 here, they are, I mean, negative 2, 0, and 2, they are all critical value and make fx equals f divided by x equals 0. So I just put all this value equals 0. Right? So later on, I don't have to worry about that. Okay, now from the interval from 0 to 2, I choose number 1, right? So I should have one here, right? So you wanna also check the number 1 for f divided by x. You're gonna have 4 times 1 cubed. So this is positive 1 minus 16 times 1. And you will have 4 minus 16 is going to be negative 12. And that's give me a negative number. So that should be a negative. And for the fx, it has to be going down, right? Decreasing. And up here, it should be a relative maximum, right? Okay. Okay. Also, For the last interval, I have x equals 3 as a test spot. So I have f equal 3. Gonna be, maybe I have to move down a little bit. Okay. So I have f divided 3 equal to 4 times 3 minus 16 times 3 to put a cube here, and I have so using the calculator better. So I have 4 times 3 to power 3 minus 16 times 3, and I will have 60, and that is also greater than 0. So I have greater than 0, positive, and it's going up because the f equal x is positive. So I'm gonna have fx in here at x equals 0. That will give me a relative minimum. Okay, so now after having step 3 2 already with a side chart, I'm gonna go to step 3, which is make a conclusion. Okay, so let me change the color to be red here, and then now I'm gonna say add x. Oh, actually, I have here. So the side chart is the one up here, and so for the step 3, I'm gonna make a conclusion, say that if x equals to -2, if x equals to relative minima, if x equals 0, if x equals to if x is a relative maxima, and if x equals to 2, f x is a relative minima. I can just even change this, become -2 here. We equal to what is that value? Gonna be 4 times -2 to power 3 minus 16 times -2 equal to so use my calculator. I have 4 times -2 to power 3 minus 16 times -2. No, that is for every box. I forgot that we are using for x. So f was x4 minus 8x squared. Right? So I have -2, -2 to power 4. So I should have the see here. -2, 4, minus 4 8 times negative 2 over 2. And that should be negative 16, which is a relative minima. Actually, okay, 16. And okay, and because this is even function, so you should also have f2 will be equal to 4 times 2 to power 3. No, sorry, 2. Oh, I made a mistake. I should have here as a negative 2 to power 4, and then 8 negative 2 to power 2. And I just wanna change this to be positive 2 for this case, and I still have negative 6, which is also a relative minima. Oh, I mean, I should also say it's at the order pair, which is negative 2, comma, negative 16 is a relative minima point. And for this one, f0 will equal to 0 to power 4 minus 8 to power 4, so not 2, times 0, 0 to power 2. And that's going to give me 0 is and then I will say 0, 0 is a relative maxima point. And the last one, I would say 2 comma negative 16 is a relative minima point. Okay, and that's going to be the answer for example 4. So have color. Okay. Now I'm gonna move to okay. I'm gonna talk about example 4 here. I don't know why I have 4b. Okay, let me see if I miss some information. Okay, so 4b is still looking for the relative extrema. If we have, right, find the relative extrema. If we have 4. fx equal to 1 over x plus 7. Okay, so for this problem, I noticed that the top is just a constant. Okay, so I would love to change it to be in the power form, in the negative power form, which is x plus 7 to power negative 1. See that? So so now I can easily take the derivative of fx. Okay. So by using the general power rule, I have f d of x equal to, you're gonna take the power negative 1 here, right? You're gonna put the power negative 1 here, put it down to the front of x plus 7, right? So it was here now. And then you have to lower down the old power, which is negative 1 minus 1. Now you have negative 2. And then you have to take the derivative of inside function, which is x plus 7. Okay, so that is way you did it. Okay, and now I may have one more step, but you should know that this x plus 1 derivative will give you number 1. So you don't have to worry about that. And you're just gonna have negative 1 over x plus 7 to the power 2. I just change it to be the positive power. And for this case, you have to know that the domain of this fraction is the bottom cannot be equal 0, which means what? X plus 7 cannot equal 0 because it's going to make the function undefined. So then x, when you subtract 7 both inside, you're going to have x not equal to negative 7. And that's the reason why you have domain is x not equal to negative 7. Okay, so so I have in order to say can I solve for x? Now can I make the f derivative of x equal 0? You cannot. Okay, because why? Because the top is equal to negative 1 and the bottom is cannot equal 0, so you will never have a chance to make this makes the f derivative of x equal 0. And I say f derivative of x never equals 0. So, and also we noted that says x equals to negative 7 makes f derivative of x is undefined. Okay. However, this is not the critical value. Okay. I'm gonna take some step here so you don't forget it. Step 1, you are looking for find the critical value. Okay. But after but you okay, so at here when you say x equals to negative 7, make the derivative of x is undefined, but it is not in the domain of x. So x equal to negative 7 is not the critical value. Okay, so step 2, set up sign chart for just a chart. So in this case, you still have to put to draw the number line, right? And it's in this case, even though you don't have the critical value, but you have a special case, a special value that make the f of x is undefined. So you still have to put that value is on the number line. Say -7 here, right? And since you have only one special number, you're gonna divide this number line to become two intervals. And I have to have two value of x with lie on these two intervals to test. So one gonna be say -8, another one gonna be say 0. Okay, so I'm gonna just have a line to separate it, and then I have first row gonna be f0 of x, and the second row I have fx. Okay, now I know that's at -7, f0 of x and fx will be undefined. So I will just have like a thing that might undefined here. You will not have any value of f0 of x and fx in this case in x equal to -7. So now I'm gonna check for the interval from -infinity to -7 by plug in f derivative of -8, right? So I have what? I have f net f -8, f derivative of -8 gonna be -1 over x plus 7. So which is -8 plus 7, and then square. And then I'm gonna have what? -1 over -1 square, which is -1 over 1. And that gives me -1. That's a 0. So I have f derivative of x is a negative. And f derivative of x when x equals 0, I have -1 over 0 plus 7 squared. And then I still gonna have -1 over 7 squared, which is 49. So I still gonna have a negative number. So say, I'm gonna just equal to -1 over 49 and then 0. So then I still have a negative one, a negative here. Oh, and I forgot to move to the fx. Since f derivative of x is negative, then fx has to be decreasing. Similar with this interval from -7 to infinity positive, you will still have going down. And since you don't have any you don't have anything for since you don't have let me see, any value that make that they're gonna make the function fx is decreasing increasing, right? They all keep decreasing from -infinity to +infinity. So you will not have the relative achievement. No relative achievement. Okay. For this guy. Okay. All right. Okay. Almost there. So now I'm going to talk about absolute maxima and minima. Okay. So absolute maxima is the I gotta say is the highest value of y. Okay. So it may be relative maxima, or it maybe is a point that not a relative maxima, but it have a value higher than the relative maximum. So it's still called is absolute maxima. Okay, so let's say for the first figure here, you see that we have right now we have two relative maximum here, right? And one relative minimum. Okay. So I'm gonna look from A to B. I just consider from A to B, and I'm gonna look for the value that highest, the highest value of the function. So I'm gonna see that at here, at this relative maximum, I noted that we're gonna have the highest value of y, right? So we call it is absolute maximum. Okay. Similarly, if you move to the next next one, you will see that we have a relative maximum here at this one, but it also is an absolute maximum because it's the highest value of y, right? Okay. For this, move to the next column here. You see that you may gonna think, oh, maybe this point at here with its highest value is gonna be the absolute maximum, but actually no, because at here the graph have a hole, right? So there's no value at this point, and we're gonna since there's no value at this point, we're gonna say we don't have, or we're gonna have no largest y value, right? We don't have any highest value y value, and I'm gonna say Sx approach B from the left, y only approach from below, and as x gets closer to B, y gets closer to S, thus there is no largest y value, and hence no absolute maximum. So in this case, no absolute maximum. Okay. Okay, so I'm gonna talk about absolute minimum, or absolute minima in here. So for the absolute minimum, you're gonna find the lowest value of y on the graph. And also the absolute value minimum could be also a relative minimum. So for example, in number 1 here, you see that we have a relative minimum here at this point, but it is not a lowest minimum, and the lowest minimum, or the lowest value of y is here, and we call it it is absolute minimum. Okay. Now for the number 2 here, you notice that the lowest value of the graph of the y value from A to B maybe is here. But the thing here is there's a hole. So we similar with the absolute minimum, absolute maximum in the third case here, we have no absolute minimum for this second case since there is a hole um, at the minimum at the at the lowest value of a function of the graph of function. So again, there's no absolute minimum in this case. Okay. And the last case, you see that you're gonna have the absolute minimum at the lowest point, which is here. Okay. So that is absolute minimum and absolute maximum. And let's we go ahead and do example 5. In example 5, the question is a constructs a side chart for the graph shown in figure 16 and uses to construct a summary table for the function. Okay, so so this is the figure 16, and I would like to construct a side chart. Okay, so I'm gonna have a number line here. And I will have I don't want to have from infinity, negative infinity to positive infinity, because the graph start from 2 to 10, right? And I will have some special value on the number line. Week gonna be 4 is the first one, right? And I'm gonna put 4 here. Second one should be 6, right? 6. And third one is 8. Okay. So okay. So I know that the graph will go down and along with the vertical line when x equals to 10, right? So x will never go to 10 actually. Okay, so now I'm gonna have the sine value of f of x under h interval here. So here's 6, here's 8, right? 4, and then another row is gonna be for fx, and I'm gonna separate it from 2 to 4. I'm gonna have f of x is since you see that fx from 2 to 4 is increasing. Okay, and so f of x has to be positive. I'm gonna change the color so it's make it nicer for this case. All right, and up here, right? And after x equal to 4, is the graph is going down. Okay, so I just going down. And seeing the fx is Going down, that means decreasing. That f of x gonna be negative. Okay. And from 6 to 8 is going up again, is increasing. So then I'm gonna have positive for the f of x. And similarly, from 8 to 10, it's going down. So I'm gonna have negative here, right? Okay, now I may have to think about the value of f of x for each of these special case. Okay, so at 2, the f of x will be no value because it's really start point. I mean, you don't want to have the differential at this point. Okay, so I should gonna say undefined here, right? For the 4, this part, right? You will also have undefined for the f of x. Because why? Because this like a cusp. Remember one of the 3 case. Let's make a cusp. So then you don't want to have you don't want to have the f of x in here. So do not exist for this one. And for at 6 and 8, you see that f of x is smoothly go through. So I'm gonna have f of x in here. At x equal to 6 and 8 had to be equal to 0 because these are critical value. Okay. And now I would say I would like to find the maximum or relative maximum and relative minimum for fx. So at 2, what is f of x? Say f of 2, what is it equal to? I have f of 2 equal to 2. So I put 2 here. And it's keep going up and until here it's going down. Then I'm going to call this as a relative maximum. And what's the value of y in here? I know that it is 4. It is I say 4 and 4. So f of 4 equal to 4. And next one, I have the fx is going down at 6, and x equals 6, and then it's going up after the right hand side of 6. Immediately. So then this should be relative mean. And it's at 6 and 1. Okay. I'm going to clean up this so we can see it clearly. 6 and 1, see that? So f of 6 equal to 1. And at x equal to 8, I have f of 8 will be equal to 9. See that? So I have here as a relative max. and then is 8 and 9. Compared with two value of with two, so you see that there's only two relative marks, and the highest value in here has to be the absolute value maximum or absolute maximum. So I'm gonna say here also is absolute max. Okay. And we don't want to have, I mean, because the graph is just triangle to along with 10, so you don't want to see it's maybe become like a negative infinity because it's going keep going down, right, to that. So so I'm gonna look like to say the lowest point in here, the lowest value in here has to be, the absolute minimum in here has to be this part, and I'm gonna call relative minimum, or which also is absolute minimum, is a 6, 1. Okay, so that is a side chart for this problem. And now I'm gonna move to the construct a summary table for this function. Okay. Okay, so now first column I have to have the interval or the value of x, right? The first special value is 2, so I put 2 here, and I'm pretty sure f of x in this does not exist, so I put any, and f of x in here I know that is 2, so I put 2 here. Okay, and then the behavior of x is 2, so because it doesn't change, so if I behavior at actual 2, it just stay there at 2. Okay, and then the next one is interval from 2 to 4. I noted that from my side chart, I have f of x had to be positive, and fx had to be increasing. See that? So then, and also the behavior of fx had to be increasing. Okay. For the interval or for the value of or for another value or the special value is actually 4. It will also have to be DNE, but does not exist because of the curve. So I'm gonna say this curve. Okay. Then you have fx is equal to 4, and 4 will be the relative maximum. Go down here, I have 4, 6 from the interval from 4 to 6. I notice that the fx is increasing, the graph is decreasing there. So then the f derivative of x has to be negative here, and then the behavior of x has to be decreasing. Another special point is a critical value, which is 6 here. That's gonna give me f of x has to be equal to 0, and fx equal to 1, and also it's 6, and the behavior of x is give me 6, 1 is relative mean, and also n is an absolute minima. Yes. Yeah. Oh, I see. I see what happened. Oh, so I'm gonna select it. So here. Okay. And from 6 to 8, I notice that the graph is increasing. The x is increasing. So f of x can be positive, and behavior of x is also increasing. Okay. And the special case when x equals to 8, I'm pretty sure that is a critical value. And that's giving me f of x to be equal to 0. And the 9 here is a value of x. And 8, 9 is going to be the relative maximum and also absolute maximum. Let me just make it shorter. Okay. So now the last one is interval from 8 to 10 is decreasing. So then f of x has to be negative here. See that? So so then behavior of x has to be decreasing. Lastly, at the value x equals 10, you know that the f of x has to be negativity, and we will not the f of x will not exist, and the behavior of x will be approach to vertical asymptote, which is x equal to 10. Okay. For this case, for this special case, for the special value x equals 10, we don't want to really consider it in this section. So I move down here. Okay, so we have let's see, only one modeling problem. Okay, so let me try to do this problem. This problem, example number 6, is very similar with one of the problem in the homework. So let's take a look at that. The manufacturer of lightweight, durable containers is contracted to make round cylindrical containers that hold 25 cube inches of liquid. The material used to construct the side of the can cost $3 per inches per square inch, and the material used to construct the top and bottom of the can cost $4 per square inch. What radius will minimize the cost of the can? The function relating to the cost, C in dollar, and the radius, R in inches, is CR equal to 8 pi r squared plus 377 over r. So remember that this this formula is this function is present for the cost of this problem, and its graph for r greater than 0 appear below here. And the question is estimate the answer to the nearest inch. Okay, I would like to show you the way by presenting this problem by hand, right? Maybe in the homework you just answer the number. It just give me the number of the answer. But the thing is, how can you solve this problem? Okay, how can you show the work to me? So please focus on what I do now. Okay, so okay, so the main question in here is what radius will minimize the cost of the can, right? So I'm gonna say, okay, r equal to question mark. That make the c is a minimum, right? At the graph here, you can see, oh, it's look like r gonna be equal to 2 here, right? Okay, but the thing is, how can you present it? Okay, how can you show me the work for this part? All right. So what you do is you gonna say, okay, first you need to take the derivative of the CR, right? So so C derivative of R gonna be equal to, remember that 2 pi, 8 pi in here is constant, so you still keep 8 pi. And now for the R square, you had to take the derivative of R square. That's gonna give me 2, let me change the color, 2 put down, and then R, and then 2 minus 1, plus with, okay, so for the last term here, I just gonna change it to become power form. So 8 pi r square plus 377 times with r to negative 1. So then now you're gonna have 377 times with negative 1 times r to the power negative 1 minus 1, which is negative 2. And now you're gonna simplify to get CDU r equal to 16 pi r to the power 1, which is just r, and plus, or actually minus 377 r to the power negative 2. Okay, so in order to find the minimized cost of can, you always go to step 1 is try to find the critical value, right? Find the critical value of the function. So I'm gonna write and find the critical value. And in order to find the critical value, firstly you need to put you need to find the c derivative, the derivative function, and then you're gonna put the you will set the c derivative of r equal to 0. Okay, and solve for r to get the critical value. Okay, so let's set it up. I have 16 pi r minus 377. I'm gonna change it to be, okay, sure. Actually, I'm gonna just put it at 2 here equals 0. Now I'm gonna rewrite it as 16 pi r minus 377 over r squared equals to 0. And now you're gonna have what? You should do you should multiply. I mean, you should make the same denominator. So you're gonna have to do multiply the first term with r squared over r squared here. And now you're gonna have what? 16 pi r cubed minus 377 divided by r squared equals 0. And then we'll like say, in order to solve a rational function or rational equation, you're gonna just make the top here equal to 0, okay? And then solve for r. So I have 16 pi r cubed minus 377 equals 0, okay? And divide that r cannot equal 0 because the bottom is cannot equal 0. That make the function define. Okay, so now I'm gonna have add both inside by 377, have 16 pi r cubed equal to 377. And then I divide both inside by 16. So, or 16 pi, I have r cubed equal to 377 divided by 16 pi. Okay, now the thing in here is I am looking for the r cube. Okay, so what should I do for this guys? Once again, I want to make sure I don't mess up anything. Okay. So now I'm gonna try to do a cube root for this problem, for this equation, or I'm gonna just make both inside raised to power of, say, raised to the power of 1/3. Same thing with the cube root, but I just write as a cube root. So 377 over 16 pi to power 1/3. Uh-oh. So remember that since the root in here is cube root, okay, and since the index is 3, so we will not have the positive negative case. It's just gonna come out only one case, okay. Okay, so now let's do it. The left hand side will be equal to r. The right hand side gonna be, okay, so maybe for this one I have to use my calculator. So here's calculators. I'm gonna open it, and I say the open parentheses. See, say 377 divided by 6. No, I need to have parentheses more times 16 times with the pi. Where's pi? Second pi is here, right? And close the bottom and close the big fraction with the power of 1/3. I need to have the parentheses for the 1/3. Okay, now it should be, answer should be 1.96. Okay, 1.96. If I want to, so they want to estimate the answer to the nearest inch. So that means what? That means you will, so let me see. The problem in here is talking about the R is in inches. Okay, so seeing it in inches, so you just round up to the whole number, and I gotta say the answer has to be, let me see, so what is the answer? 1.96, right? So it should be 2, or I'm gonna say 1.96, right? And I'm gonna value to be, or I'm gonna say 2 inches. Okay, and yeah, and I think that is answer for this part. Okay, So in those, in your exercising work, you maybe gonna think you will see it clearly is true, right? But actually it's not easy. It's actually not exactly true, right? If I ask you to do like a quiz for this problem, you need to show me how did you have this number two. You cannot just give me number two, right? So these are I need to tell you today, and go ahead and do your assignment for 3.1 part 2, and I'm gonna see you on section 3.2 next time. Have a good day.